Hello, protocols, packets, and programs. It's episode 221B, as in Baker Street and Sherlock Holmes, the famous detective who solved mysteries with his companion Watson, and in one such story, provided a lesson to AppSec with the warning, how dangerous it always is to reason from insufficient data. Which means, this week we chat with Kenn from MongoDB about Queryable Encryption and designing security-focused software for developers. In the news segment, AppSync goes cross-tenant with AWS, C++ goes to zero in a bid to stop phones, HTTP 3 goes to dangerous territory in reverse proxies, Thinkst goes to great lengths in reviewing research, and more. Check for clues, and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys CloudView, the next-generation cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. CloudView enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, and prove compliance in audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. Securing the modern enterprise requires insights into massive amounts of data. NVIDIA Morpheus harnesses the power of AI and GPU computing to help protect networks in a way never before possible, enabling 100% data visibility to provide cybersecurity analysts the tools to identify, capture, and act on threats and anomalies. Sign up for a free 1-hour NVIDIA Deep Learning Institute course. To learn more, visit securityweekly.com/NVIDIA. We know that many of you are looking to bolster your security posture with cloud-native app protection and XDR. So if you haven't heard of Uptycs, put them on your radar. They offer both cloud and endpoint security in a single solution. Listeners can get Uptycs for up to 1,000 assets for a full year for only $1. But hurry, this offer is only available through December 31st at securityweekly.com/Uptycs. That's UPTYCS. This is episode 221, recorded November 28th, 2022. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
Good morning, Mike. I'm sorry for once. I'm usually sorry, but I'm particularly sorry that we're not streaming live today because everyone's going to miss our Cyber Monday sale and get that free application security tote bag.
That's right. We need to see more tote bags out here. And we also have Akira Brand. Hello, Akira. No tote bag for you, I guess, for any of us today. Sorry.
It's okay. I'll make it. Good morning, Mike.
Good morning. And for everyone who is missing our Monday sale, join our Discord channel to chat with our hosts, ask questions, customize live stream alerts, and more. Visit securityweekly.com/Discord to receive an invite. Kenn is a security engineer whose work focuses on networks and global systems. He currently leads applied encryption engineering in MongoDB's global product group. He is co-founder and director of the Open Crypto Audit Project and led formal security reviews on TrueCrypt and OpenSSL. He has directed R&D and security ops in organizations ranging from startups to nonprofits to defense agencies to the Fortune 50. His work on network security and forensics has been cited by the Wall Street Journal, Reuters, Wired, and the BBC. Hello, Kenn. Thank you for joining us.
Hey, Mike. How are you? Great to join you.
It's wonderful to have you here. I'm not sure we fit quite in the same realm as the BBC and Wall Street Journal, but we'll do our best. But we're going to talk about Queryable Encryption, but you have quite a wonderful background that I think gives insight on both the problem side as well as the solution side of this space. So I was wondering if, before we dive into that part, if you could just give us a little bit of your background.
Sure. Yeah, I definitely took the different path, I think, than a lot of folks in the security world. So I started in my academic work in cognitive neurobiology, so computational modeling, signal analysis, things like that. I spent several years at the National Institutes of Health Clinical Research Center and got to work on some really cool, fun early technology, so functional MRIs, PET scans, brain imaging, really cool stuff. And at some point along the way, I realized I like the methods and the equipment and the tech more than I did the science. And so wrapped up a couple research projects that I've been involved with, and then ended up in the clinical trials world. And so I spent quite a few years with pharma. So when you're building systems that are, in pancreatic cancer trials or, pain medicine or things like this, these are compounds that are the first time ever used in humans. The kind of software and the systems that are in place for that, it's just a very different level of kind of, seriousness and maturity. And so really enjoyed that, but ended up kind of inheriting defensive ops for these clinical trial sites around the world. And so, a little bit of self training, but then, over time working with, lots of really skilled engineers, went into kind of the CISO world, and then some consulting, and then eventually ended up in sort of squarely in the security space. So that's where I've been for the last 10 years or so, is on sort of applied encryption and privacy enhancing technologies.
Yeah, and clearly well informed about that confidentiality part of the classic CIA triangle there. And that brings us to the idea of queryable encryption as we kind of step slowly into this topic. The idea of one is just we have great data stores. We want to protect it, perhaps, just data at rest. But we also want to encrypt the data. At least that's the general checkbox level of concern here. And one of the easy ways is to just say, well, we can encrypt it, and maybe we can do equality comparisons. Is this encrypted blob equal to this other encrypted blob? But that's kind of falls apart, and it doesn't support a lot of use cases. So what are the what are the use cases that you started to see that some of those problem sets that said, well, maybe rather than AES SIV or some other some very specific modes of operation here, get us into something that's more useful for DB admins or for programmers.
Sure. Well, actually, you kind of hinted at sort of what I see as a bigger problem, which is just a shared lexicon, right? A shared language. I think even seasoned security people sometimes have a real misunderstanding of different types of encryption on systems. So, it's sort of just table stakes these days for network encryption for TLS or HTTPS. And there's a big misunderstanding around encryption at rest, right? I mean, most of the big cloud providers, it's just sort of a checkbox, and that's true for most desktops and notebooks now. You just basically check a box, and your disk is encrypted. But there's this sort of false sense of security that, okay, I've got disk encryption, so we're good. But those are protecting things that aren't running. They're protecting disks when your machine's turned off, or when the server's not started up, or when a virtual machine's not mounted. And so a lot of their use kind of drew from in the regulatory world, particularly in HIPAA, right, where the regulators basically said, look, if you've got a laptop and you've got sensitive, patient data, if the hard drive is encrypted and it's, you're a victim of petty theft, or it's stolen or it's lost or something, then it's the difference between maybe a $25 million penalty and no notification at all. And so I think a lot of tech leaders really focused in on that, but they missed kind of the bigger point, which is none of that has anything to do with active attacks. Anything that has anything to do with sort of criminal black hats or sort of common breaches and things, right? And so over the last few years, people have been thinking more about end-to-end encryption, right? A type of client-side encryption. We see this in the messaging world, right? With Signal and with WhatsApp. I mean, those are hugely popular. I think people have a pretty decent mental model in their mind. And what we've done with queryable encryption is we've sort of taken that and moved it to a database idea. So the notion is, what happens if the service provider or the cloud provider, Amazon or Google or Azure, make a mistake, or they have an inside attack, or they have a misconfiguration, or there's a breach or something? Can you structure data? Can you encrypt data in such a way that you can still use it on the cloud, right? So do these massive computations, but have it in a way that the service provider can't see anything. And that's really what this technology is about, and that's why we're super excited about it. There's several different techniques in privacy enhancing technology to sort of tackle this, but we chose one that's been sort of popular in the academic world for several years, but it hasn't really seen any use in the in mainstream tech. And so, love to talk to you more about that and sort of how that works and how people are using it.
Yeah, and I think one of the things you mentioned there too is you meant like structured encryption. Now, coming at this again with a maybe we don't have as strong of a shared vocabulary as you're pointing out. Right. When I hear structured, I think of I'm going to throw out another ECB mode, the classic mode for call it Crypto 101 classes or simple AppSec, where you have a encrypted version of the Linux Penguin, but because of ECB mode, you see its broad outline, because of the nature of how the blocks are individually encrypted rather than chained together. So right. When you have this, how does structured encryption, clearly you're working with smart people, you're a smart person preventing these types of basic problems, but there's also got to be something more to this that's also saying we're able to do more than just an equality search, and that's what becomes very appealing from a product perspective.
Yeah, so you touched on a couple of things. One is that I think even the notion of AES encryption, right, of one of the most widely used types of encryption on the planet, by technology people is poorly understood. AES doesn't protect strings. It doesn't protect streams of text. It literally protects a few bytes. And so it's a very low-level primitive. It's a very low-level building block, an algorithm. And in order to use it in any meaningful way with browser data or with text data or anything else, pictures, you have to actually figure a way to encrypt successive blocks. And it's those edges. It's not really the core cryptography where we see continual failures after failures after failures. It's sort of the glue that holds things together. And so, as you mentioned, ECB is a type of block mode where you use successive encryption with AES, and that's you raised that example because ECB encryption is one of these techniques that, if not used properly, it sort of reveals the entire pattern of the original message that you're trying to protect. And the classic is a picture of the ECB penguin, the Linux penguin, right? So it's encrypted, but if you look at a picture of it with ECB encryption in a certain structured mode, the structure of it sort of gives away what the message itself is. But that's a little different. So what we're talking about is how do you take some of these established like primitives, like AES, like HMAX, like hash, like SHA-256, that are really well understood, really well characterized. They've been researched, they've been cryptanalyzed really well. And how do you put those things together to do things like end-to-end encryption? And so structured encryption is one of the ways that works. I think people may have heard about homomorphic encryption. They may have heard about multi-party computation or differential privacy. These are different types of techniques that in many cases are getting to the same point around confidential computing. Pardon me. Structured encryption sort of turns that on its head, and what it says is, in the database context, what if your messages were encrypted with standard AES, just modern constructions, but we built a type of search indexes that were efficient and really quick, really high performance? That's the basis of structured encryption. Of queryable encryption.
Yeah, and you mentioned too, so homomorphic encryption there. And for listeners, we are avoiding going any depth into the math behind all of this. But one of the promises of homomorphic encryption is that you could also perform operations on data.
Right.
But it tends to be slow. And you mentioned now indexes too. So clearly, indexing databases. This is one of the ways just to make unencrypted databases quicker, be able to find what you're looking for. So there has to be an engineering angle to this, because you actually, what was you're leading applied encryption. So there's an engineering background to this. So, how do you handle, or how do you, what are the performance trade-offs here that you're looking at, or, how does this compare to something like homomorphic encryption?
No, that's a great question. So, one of the things about different types of message encryption, generally speaking, is it very much depends on what your time basis is, right? If I'm streaming you something in real time, you're getting it as it comes. In a database context, it's very different. Indexes aren't something that's nice to have. They're absolutely required. They're a critical type of data structure for the entire system. If you have a few hundred records or something, it's, it's not a big deal. But when you get into truly large-scale systems, hundreds of millions of documents, petabytes of data, then it really matters that you have efficient searches, right? And so one of the things about homomorphic encryption I think that's misunderstood is it's a technique that's meant to do confidential arithmetic, right? So adds, multiplications, and theoretically you can take those basic primitives and build a whole lot of things around it. But it's sort of like the same idea of if you have Excel can do a whole lot of things, but would you want to build an encrypted database inside Excel, right? It may not be the best technique. And so where homomorphic encryption, I think, plays a role is for certain types of, shared data where maybe you've got like a fraud detection system and an ML, machine learning, startup that has a really cool technology, and maybe a bank that has, fraud data on credit card information. And they need to do certain operations, but they don't want to find out sort of what the other one's holding, the information they're holding. And so it doesn't really make sense in the case of general purpose databases because, for one thing, it's interactive. It requires multiple round trips back and forth to get the data. There are several techniques where you have to do really advanced machine learning to basically get rid of noise. And fundamentally, the biggest problem with it for sort of general purpose databases is it's linear, right? So as your documents increase, your queries increase as well. And so they could be multi-seconds, multi-minutes, multi-hours possibly. And that's just, that's a sort of a non-starter for most transactional systems and most sort of, CRUD-based, read, update, delete kind of web apps that we see today.
No, indeed. Yeah. And that's the key point that I was also curious about too. Just how does this scale? Because a crypto project that can deal with a gigabyte of data is much different from one that actually works on, millisecond measured latency on terabytes of data, which then maybe brings us to that developer side, the consumer side of these APIs using it, because it's one thing then to have a well-seasoned engineering cryptography team being able to build this, but people have to use it. And for as much as the academic rigor can have, formal proofs that this is, these are the ways to attack this. You need, 2 to the 64 pieces of data before you can, pull off a successful attack. An implementation error or a misconfiguration, that suddenly kills everything. So, what went into the design of this, just in the sense of key management, making it hard to do the wrong thing as developers actually consume this database?
Yeah, no, that's a great question. I mean, one of the things that we decided very early on when we first started the project was, we're good at distributed systems. We're not cryptography PhDs. And so one of the teams that we worked with early on eventually was acquired by MongoDB. And so now we actually do have an advanced crypto research group inside the company. I think we have 5 full-time PhDs now, and we're bringing in visiting scientists and students as well. And so sort of just getting the fundamentals correct is crucial. But as you point out, like none of that really matters if you give developers 27 choices and sort of weird defaults, or they have to read a whole tome on different types of math before they can use basically do a hello world with encrypted message. And so what we ended up doing was taking a very opinionated approach. There are configurations and there are things that you can tweak for certain situations, but generally speaking, you don't make any crypto decisions. The message encryption is AES in authenticated mode. It's sort of misuse resistant. It's abuse resistant. You can't twiddle with little bits here and there to try to figure out what's called an encryption oracle to try to get information about the underlying clear text. In terms of the APIs, there's so many different cloud APIs out there for Amazon and Google and Azure, HashiCorp and all these things. Mm-hmm. And so what we did is we built those in natively to try to make it just as easy as possible for developers to use, right? And so you don't have to know all of the different methods and properties and things of Amazon's key management system. You need to create a limited key. You need to create a really narrowly scoped role that its only job in the world is to do encrypt, decrypt operations on this key, and then use that for your project. It doesn't have anything to do with like spinning up a new instance or new VMs or security fabrics or anything like that, network fabrics. And so, yeah, we ended up spending probably 85-90% of the time on the developer side, on the APIs, making it easier for developers to use, not on the crypto side.
Now that's interesting. I'm curious too. Then, how did that also relate to testing the software, either in the looking for those oracles, for example, in the implementation errors, or just testing it in general to say, we have a lot of unit tests, functional tests, or just a particular approach there. And one of the reasons I'm asking is that we've talked about the importance of testing in the past and approaches to it in the sense of what actually feels useful for finding bugs, finding flaws, and what tends to be just, we're writing this because we thought we're supposed to write this, but it's not giving us good feedback about the state of software.
Right. I mean, we could do a whole show just on MongoDB's engineering process because, I've been with the company now about 5 years, and when I first came on, it just blew away any of the practices I'd seen anywhere else. But to give you a sense of like any binary that we release, any of the driver versions, they'll have had tens of thousands of unit tests done, and they'll be done on every possible combination of Go and .NET and Java and C#, C#.NET on Windows, C#.NET Core on Linux, on every flavor of Windows, every flavor of Mac, every flavor of Debian, Ubuntu, etc. And so that's sort of just table stakes, because we do all kinds of fuzzing and static analysis, things like that too.
Oh, fun.
But in terms of queryable encryption, because this is kind of it's a new sort of domain, for developers who may be using Mongo, we did a lot of like really focused developer, one-on-one sort of testing, where people would come with a Mac, they literally never had Python installed, or they never had Java installed, or maybe they were 10-year veterans, and like they could tell you every nuance of the JVMs and all the tweaks and things. And so just literally walking through them to step by step setting things up. Going through the docs, going through the tutorials, seeing where the pain points were, seeing what was clear, seeing what was confusing. I mean, there were some times where we would see people on a Mac, like programming in Go, and they were actually pulling out the X code to like compile stuff. And we're like, no, you don't need to compile it any more than you need to compile the database. Like, yes, you can. I mean, it's open source. Like, you can go on GitHub and do this, but no. Like, what was not clear? And so we really change our messaging in different places, and it's critical you make. If I were sort of giving advice to, me 10 years ago, it would be do really, really good documentation and tutorials, because otherwise the web is going to do it for you, and they're going to be pretty lousy often, and then you're going to be dealing with that for like 7 years.
Just searching Stack Overflow isn't a success. Is this what you're telling us?
Gosh. Yeah, no, I actually have a DAC where we had some of the top posted things. It was like, when I do SHA-256 on Java, it does this, and I get this output on this text, and then if I do it on Python, I get it's like, you've got so many things you've got to deal with as a developer. You shouldn't have to worry about like, does multiplication work, right? You don't normally think about like, does red mean red on a screen? Like, you know what I mean? And somehow, but in the crypto world, you sort of have to get down and, how to create the entire souffle, right? And you shouldn't do that.
No, and I think that's a wonderful message, that it's the emphasis, as you said, on documentation and actually talking to developers and seeing how they use it, rather than assuming this is how you're supposed to use it, and if you mess up, you're doing it wrong. It definitely does away with that canard of developers are dumb or they don't care. It's more of, what if the documentation was better and we gave it, we helped them. One of the other things, I want to come back to this idea of the engineering side of things, and talking about developers, search performance trade-offs. It sounds like you're building that encrypted index now. So there's a trade-off here of encrypting the index and just trying to get a sense of, when you're talking about like a use case, we're kind of alluding to homomorphic encryption, doing operations on data without revealing the underlying data. That's something that doesn't necessarily scale. They're talking about seconds to minutes to potentially hours. what would a developer expect here for rebuilding an index? Not that you have to rebuild an index from scratch, but perhaps sort of what are the performance characteristics of an application, the things that developers are thinking of about writes versus reads versus throughput, things like this.
Yeah, it's so crucial. And I think so many times in the security world, we sort of just hand wave a little bit over that. And I think that's a mistake. What we've been really clear in all the documentation, in our tutorials, and in developer conferences and in our own conferences and things is, if you need really heavy duty insert write performance, this may not be the best technology. It's not designed for that. What it's designed for is really performant reads, right? And most CRUD applications, it turns out, are about 85-90% reads and occasionally writes, right? You'll do updates on session information, on sales, on contact information, things like that in many cases, but it's really read heavy. And so if your app is doing lots of reads, then it should work pretty well for you. I mean, we're still doing all kinds of, empirical performance tests with, a lot of the big benchmarks. But typically, we're going to see in the millisecond range, right? So you may say something like, it'll be a 2 to 5x increase in performance or increase in latency. And a developer may say, well, that's terrible. But if the wall clock time you're talking about goes from 2 milliseconds to 4 or 5, is that really sensitive to your application, or is that just noise and all the other things around network and just the way you structure queries and, and just app code? And often the answer is, well, no. I mean, we certainly do have some customers in the financial services sector that are doing, like real time, like unbelievably high volume processing. And they've got to be very careful about those kind of trade-offs and really understand it. Same in the insurance world, right? So with payment clearinghouses and in the pharma world, when you use your card at a retail pharmacy, it's part of a much bigger chain, supply chain and all this sort of thing. Mm-hmm. But in those contexts, we see hundreds of thousands of transactions a minute on some of these individual data feeders. So it really depends. And when we say indexes here, they're functional indexes. They're not native DB indexes. We built this technology so it could run mostly unmodified on top of MongoDB, because there's other search techniques that we can use as well. Actually, one of the things we're really excited about, we're going to start looking at in the middle half of next year, is natively expanding it to Lucene, right? So that Elasticsearch type searches can work as well, right? So right now we're focused on equality matches. If you say, I want this social security number, this credit card, this date of birth, you can do that. We're in the early phases now of preview testing for range. So if you have birth dates that are encrypted, if you say between this age and that age, or financial values, like you're doing fraud analysis, things like that, between X dollars and Y dollars, you can do that. And then later next year, we're rolling out the string search as well, which is really cool, because that's begins with, it's prefix, it's suffix, it's substrings, things like that. If you want to see a certain keyword that's in a customer comment in a customer response database, you can do that. If you want last 4 digits of social or a credit card number, you can do that without having to sort of hack it up and have 2 different fields and so forth. And also that the person, like in a customer service role, they don't have to have the whole card number, the whole social security number to pull that record up. So and then when we look at it for sort of down the road on Lucene, that's really exciting, because then we're talking about full text search.
I'm sort of curious. I think you partially answered it when you were talking about building this as a layer on top of Mongo. How does this work with clustering? I'm guessing it's probably going to be fairly transparent, but is there any hiccups around that? Like as that index or that table gets sharded across a cluster, how does this play with that?
Yeah, I to be honest, in some of the earlier work that we did, maybe 4 or 5 years ago, there were a couple times where honestly we made a few missteps. We would start to implement some technology and weren't thinking about sharding or massive global clusters. And so, if something takes off and becomes popular and you have to sort of retrofit sharding or really large clusters, so we have the ability now, with a few clicks of a button, you can say, I want a database with 5 replica nodes, and 2 of them are on Amazon, one's on Azure, and one's on GCP. Like if you really are playing the cross-pod thing. And I don't mean like a backup. I mean live, real-time, read replicas. And the same with sharding, right? I mean, for some of the massive databases we have with in the healthcare or the financial services world, we have customers that are doing capital markets, and so they're literally moving hundreds of billions of dollars a day, and so those are just massive, financial, what do they call the core operational data stores. But yeah, so in the case of Queryable Encryption, because we're treating it natively as another type of special collection, it just sort of works. It is, and all of our tests take this into account. We do sharding tests. We do, multi, replica set clusters by default for all of our testing. So, it works, and you don't have to think about it as a developer, as a DBA, and that was because a lot of really hard engineering went into it.
Yes, I'd love to see just the documentation. It works, and and you could be done there. Yeah, I wanted to touch a little bit again on the threat models for this, because one of the things you were talking about is educating developers on either what they need to or not need to know just to manage keys, to understand the write versus read performance, basically the engineering side of using this. Right. I'm curious on the education aspect of the security part of it, and you mentioned something just now a little bit ago about customer operations people being able to blind them, so to speak, to the full data, doing full data queries, poking around, being just curious what's in there. Right. That seems pretty interesting. You pointed out too with at rest, a service that's talking to the database needs to have that decryption key for classic, database connections, just so it can operate on the data. So, maybe not everyone is as worried about just AWS, administrators or SWEs gone bad. What are some other things, perhaps even beyond that, or just other areas that you also highlight or tend to point out, or that are helpful education about the threat models that this is designed for, or maybe even not for that matter?
Yeah, no, I'm glad you brought that up. We have so many different use cases, right? We, sometimes, and I'll say this, coming from the community, sometimes the people who are the worst at threat modeling are security people themselves, right? They'll obsess about, some really rare edge condition and ignore that they don't even have, your organization doesn't even have a map of all their instances that are public facing, right? Or they have no idea, where all their Java services that are exposed to the internet live and things like that. So what we've told people is this technology is not a silver bullet. It's not meant to, be, military grade or hack proof or anything like that. We're just trying to use, modern techniques that are well vetted, that are transparent, they're open. You can see all of our commits on GitHub, and they achieve two things. One is confidentiality. It's a type of end-to-end encryption, so that you don't have to worry that the service provider or the DBA can see the data. If I'm a DBA for large Fortune 500, and my job is to sort of do security patches or backups of things to our HR system, I need to do that. But do I really need to have Mike's social security number or John's routing number for their paychecks, or how many dependents they? And usually the answer is no. And so it's just a different way of sort of dividing up privileged access. But we do, on the other end of things, have, we protect entire national pension systems. We protect entire currency platforms. So when you have these things that are like, well, what if a really well-resourced criminal black hat, were to focus for months on the platform, what could they do? Well, likely they're probably not going to go after your crypto. They're probably going to break, your not well-tested Python app or your really bad Java middleware that's 7 years out of patch or something like that. And so if you're looking at cryptocurrency exchanges or capital markets, retail or investment bankings, those threat models actually really are more complex and more sophisticated. But ultimately, these are just sort of security foundation principles, right? I mean, limit your network, limit access, have really aggressive auditing, have really good discoverability, really good observability. And then, yes, to the extent that encryption plays a role in that, because you're using a third-party provider, definitely use all the tools in the toolkit, and there's going to be a little bit of a hit on performance, and it's may or may not impact your workload depending on what you're doing. That's kind of our approach.
Yeah, so clearly a message, if I were to summarize, that context matters, perhaps. And, this isn't, there's clearly, as you would know this, there's no absolute security. This is the threat we're designed for. This is what we're not designed for that matter.
Yeah, the anti-goals, in my view, are the things that we don't talk about nearly enough. And so I think it's important that developers do. And actually, in some, your original question was around developers' notion of threat models. And I would say in many cases, a seasoned, sort of veteran developers actually have a pretty good idea of where the real sort of soft underbellies of the application stack live, honestly.
No, yeah, good point. Ask a developer, well, where did you not have enough time to spend? Where did you leave your to-dos? Where are the fix-me's in your code? That backlog that you just can't get to. That's a wonderful point. Kenn, as we're kind of wrapping up here, coming to the end, I'm curious, is there something that you would, you mentioned the source code is available. Is there a call to action that you'd love to send out to listeners, whether it's looking at code, understanding code, or just something even more general in the cryptography space that you've had your eye on?
Well, I'd love for folks to take a look at it. I mean, so the technology's in preview now. We released this June at our big annual conference. So pick your language, pick your application stack. If you're on Mac and you like Node.js, we've got tutorials. You should be able to get up and going in like 10 minutes, kick the tires, see what you think. Give us feedback. We monitor all of our, all the standard development channels, all of our community forums, Stack Overflow, all these things. So if you have a question, we're pretty easy to get a hold of, and we'd love for developers to try it out and see what they think.
Is there a particular version of Mongo that people can find us in?
Yeah, so it's the public preview started with 6.0 that we released in June. Yep.
Awesome. That's wonderful. So yeah, a wonderful conversation on confidentiality, documentation, and oh, by the way, some encryption as well. But this was a pretty cool topic, at least that appealed to me, Kenn. So thank you for taking the time. And I think we're going to have you back on just to talk about that testing angle too, since you've dealt with so many different types of systems. So thank you very much.
All right. Thank you all.
Thank you, Kenn. Thank you, Kara. Thank you, John. Thank you, everybody, for listening. We're going to take a quick break now and return with news of the week.